Hey class, Mr. Hanji here. Today we're going to be taking a look at section 1.2, which is going to deal with angle measures and bisectors. So for today's lesson, we have two different learning goals. Our first learning goal is you will be able to name, classify, and find the measure of an angle. So we're going to talk about angles today as our main point. We're going to look at how we go through and name them, just like we did yesterday in section 1.1. We're going to talk about how you classify them based off their measure and how you can find the measure of that angle. Next, we will be talking about how to draw an angle bisector and use the angle addition postulate. So we're going to talk about what an angle bisector is, what it looks like, and then also we're going to take a look at the angle addition postulate, which is very similar to the segment addition postulate. So with that said, let's go ahead and get into our stuff today. And what we're going to take a look at first is angles. So let's first talk about the definition of an angle. Now, an angle is a figure that's formed by two rays with the same endpoint. Okay, so if we look at our angle here in example 1a, we have two rays and they both have the same endpoint of k. The ray kj goes this direction, and the ray kl goes that direction. So an angle is just that. Now, the common endpoint that they share is referred to as the vertex of the angle. So the vertex of this angle would be k. The vertex of these angles over here would be e. So just something to keep in mind, where those two lines meet is going to be referred to as the vertex. Now, the last part here is that the rays are going to be the sides of the angles. So kj and kl is the side of our angle. Now, we're not going to really worry too much about the definition of an angle. It's just kind of some terminology. The main thing to take away is what a vertex is. All right, so with that said, let's go ahead and take a look at example 1. So example 1 is going to ask us to name the given angles. So in parts A and B, we have two different sets of angles, and they want us to go through and name them. We're going to name these much like we did in section 1.1 with a point, line segment, plane, or ray, where we have to go through and name this specific angle. Okay, it's not just saying, hey, it's an angle, but tell me, what the letters are and which angle you're referring to. So I'm going to move this up here so we have room to work. All right. So when we go through and name angles, okay, first things first, if you want to write the word angle out, by all means you can. But moving forward from this point, we're going to use a bit of shorthand. Okay, and the shorthand we're going to use is we're going to draw a little acute angle like this. And what that's going to refer to is angle. So that saves me from having to write angle every single time. We just draw this little angle. It's not an L, so don't think that it's an L moving forward. It just refers to the symbol of an angle. And another way that you can see it would be like in example B here, when they talk about name angle 2 as many ways as you can. Okay, that little symbol is not an L, it's an angle. So if we look at example 1a, so we have our angle, the vertex is K, and then the points L and J reside on the angle. So vertex K, points L and J. Now, order does matter for how we go through and do this. Okay, and the order that matters is that you have to move across the angle from left to right or right to left. Okay, you have to go in order. You cannot jump around. So for example, I cannot say angle LJK. Okay, you have to move around the angle. Okay, there's no jumping across and then back to another point. So again, do not go LJK, JLK. You have to go from left to right or right to left. Follow the flow of the angle. Now, main thing for angles is that we're going to use 3 letters moving forward, really. For this particular angle, if I start at the left, so I have L, okay, we're going to flow through the angle, so it's going to be L, K, J. So the name of our angle is going to be angle L, K, J. And that's how you name that angle. Now, while order does matter, it does not matter which letter you start with. Okay, so if I did L, K, J, I can also do J, K, L. So another way that we can name this angle is going to be J, K, L. So if you want to start at the left point or at the right point, it does not matter. You just have to flow through the angle. And the key here is that the vertex, in this case K, is that middle letter. Okay, as long as the vertex is in the middle, that's going to be our main guiding point for naming. Now, if you have an angle that's off by itself, okay, so as you see with this angle, there's no other angles attached to it. There's no other drawings or anything else on the figure. It's just this angle. This one has 3, really more than 3 angles in it, based off the drawing. So we couldn't go anywhere further than just this. But because this angle is by itself, there is another way we can name this, and it's going to be based off its vertex. So I could name this angle K. And that would be a third way that I can name this angle for that. Now, there is one last way, is if you have a number kind of inside the angle here, so we're talking about this angle right here, they've attached the number 1, so I could also name this angle 1. Now, most common way that you're going to see me name angles moving forward is going to be one of those 2. Okay, I'm going to use generally 3 letters because it helps us be more precise. Because if I come over here and I said angle E, you don't really know which angle I'm talking about. I could be talking about this angle, this one, and so on. I could go through and find at least 3 more angles from there. So I'm generally going to be pretty specific and use 3 points, and that's what I suggest to you. But just be aware you can name it by its vertex if it's by itself, or by the number that's inside. Just be careful that if there's a degree symbol next to the number, that is the measure of it. That's not a way to name it. All right, if we take a look at B, so for part B here, it talks about name angle 2 as many ways as you can. So angle 2 refers to this angle right here. So it's going to include these sides of the angle. So we want to go through and name that angle as many ways as we can. And they gave us our first way to do that, and that is by saying angle 2. Now, there are 2 more ways that we can go through and name this, and we're going to use the 3 points on the angle to help us. So if we go with our first one, if we start with point A and we move through the angle, it's going to be angle AEB. Now, notice for that way of naming it, AEB, okay, I did not jump across the angle, I just went with the angle. Okay, if you did ABE, that would be incorrect. Okay, you're referring to something totally different. Again, the vertex needs to be at the middle of your name when you use 3 points. Another way that we can name this is if we start with B, it would be angle BEA. Again, doesn't matter which point you start with, as long as you use 3 points and the vertex is that middle point, then you should be okay. All right, so that is how we're going to go through and name angles. Next, we're going to take a look at how we measure them and how we classify angles based off their measure. So this part right here, what it's going to talk about is how we measure angles and what measurement unit we use. Know that we are going to use degrees as our form of measurement for angles. It's the most common way that we measure angles, and it's going to be how we use it for geometry. So if you see a little degree symbol next to a number, that refers to its measure. So 17 degrees would be the measure of an angle. Now, quick memory flashback is that every circle, its measure is 360 degrees. So 360 is going to be our base point. So when we say 17 degrees, we're saying it's 17 of 360th of a circle. So it's 17 parts out of 360. Don't really worry about that. If that confuses you, you're okay. Just know that 17 degrees would be a way that we measure it. Okay? So degrees is our measurement. Now, the last thing I want to mention in this part is a little bit more of a shorthand. If you see an M in front of the angle symbol, so here we have M angle A, M angle PQR. The M is going to refer to the measure of that angle. So this means the measure of angle A or the measure of angle PQR. Whenever you see that M, it's asking for the measure of that angle, or it's going to tell you what the measure of that angle is. All right, so now that we've talked about the way we represent the size of angles, let's talk about how we classify angles based off their measure. Now, these 4 different classifications may be familiar to you from past math classes, but we're just going to review over them right now. The first one is going to be an acute angle. Okay, an acute angle's measure is from 0 to 90 degrees. Okay, so an acute angle generally looks like this. Okay, it's going to be less than 90 degrees, and it's going to be smaller than a right angle. So less than 90 is generally how you're going to think about an acute angle. So less than 90 degrees. Now, if we talk about a right angle, the measure of this angle is exactly 90 degrees. So anytime that you hear us talk about a right angle, know that that equals 90 degrees. You are going to hear right angles referred to throughout this entire trimester, most days. So whenever you hear me say right angle or you read right angle, know that it is exactly 90 degrees. Now, a few things symbol-wise. If you ever see the box in your angle like this, that always denotes that it is a right angle, so it is always 90 degrees. So whenever you see that box in a corner, that means that that angle is 90 degrees. Now, an obtuse angle, for our third one, is going to be from 90 degrees to 180. So anything larger than 90 degrees is going to be an obtuse angle. So if your angle measure is greater than 90 degrees, it's an obtuse angle. Now, there are angle measures in a classification greater than 180. We're not going to worry about that at this time. And then the last one is going to be a straight angle. The straight angle's measure is exactly 180. And if you look at this angle, it's just a straight line. So if you ever hear us ask, what is the measure of a straight angle or a straight line? That just means that it's equal to 180 degrees. All right, So that is how we will go through and classify angles based off their measures. Really just keep in mind acute, right, and obtuse, and that's really going to be the main ones we talk about. All right, next for example 2, we are going to talk about how to go through and find the measure of the angles using a protractor. Now, in case you have not used a protractor or it's been some time, okay, we're going to go through and practice this. Now, I realize that you very well might not have a protractor in front of you. Don't feel that you need to go out and get one or specifically have one for this moment. Okay, it's really only going to come up in this section for maybe a question or two, and most of the time you can have a pretty good estimate of what it is. Now, a few things about a protractor. The bottom part is going to refer to as a ruler, as they have for us here. It's not going to be really necessary for us. The info that we need is the numbers that go up and around. Now, there's two sets of numbers. It goes 10 through 170, and then 10 through 170 that way. There is 180 degrees, and that would be down here, or 0 degrees, if we are ever going through and measuring. Now, let's go through and actually try to measure an angle, as it will help us know which number to use. Really what I'm going to suggest is when you look at an angle, think about it. If it is an acute angle, remember you want your numbers to be less than 90, so then you would use the numbers less than 90. If it looks like it's larger than 90, it's an obtuse angle, you're going to want to use numbers that are larger than 90 or larger than 90. So, let's go through and practice with example 2a. Now, first thing, this part right here where these two lines meet, that's where your vertex needs to go. Okay, so the vertex of your angle, that's where that point needs to go. So it needs to go on the angle like that. So this point is on the vertex. Now, what you need to do is you need to take one of these two lines and line it up with one of the sides of your angle. So I'm going to take this part right here and I'm going to rotate it so it's straight with that line. Okay, so you shouldn't be able to see it then. So this point is on our vertex. That line matches up with this part. And then you're just going to look at where the other side, so this starts at 0, and it's going to cross our protractor here, about here. So it's either going to be 40 or it's going to be 140. Well, this angle is an acute angle, and it looks like an acute angle, just like this. So if it's between 40 or 140 degrees, that has to be less than 90. So the measure of angle MNP is 40 degrees. Okay, so if you're wanting to write that out, it's measure of angle MNP equals 40 degrees. All right, so if we take a look at B, so for part B here, again, I'm going to go through and put that point on the vertex. So where these two lines meet, right here, needs to go on the vertex. Now, I just need to match one of these lines up on the other. So I'm going to match that line up. And we see that the protractor, or our angle is going to cross the protractor and it's going to cross through here at an in-between point. So it's either 75 degrees or 115. Now, because this looks like an obtuse angle, that means that we're going to go with the number that's larger than 90. So it's going to be 115 degrees. So the measure of angle JKL is 115 degrees. Alright, so that is your quick refresher on how to use a protractor and find the measure of an angle. Don't worry if you do not have a protractor. It's only going to come up in this section, and it's just something I want to talk about so you know how you could go through and measure an angle. Alright, so on to the next side. What we're going to talk about first on this side right here is going to be an angle bisector. So an angle bisector, okay, it's just like what we talked about with a bisector the other day. A bisector is going to cut that figure, so in this case an angle, into two equal parts. So an angle bisector is a ray that divides an angle into two angles that have the same measure. So in this figure right here, angle ABC was the original angle, and the ray BD is the bisector of this angle. So it cut angle ABC in half. Now, because it cuts it in half, I know that angle ABD, so this angle right here, is the same measure as angle CBD. So these two angles are the same measure. So let's say that the original angle ABC, let's say that it was 70 degrees. So if we bisected the angle, we cut it in half. That means this part is 35 degrees, and this part is 35 degrees as well. So it cuts the angle in half. They have the same measure, and we're going to denote that by drawing these. There would be the angle form of a tick mark that we talked about with segments. Now, the angle addition postulate is going to be very similar to the segment addition postulate. So the angle addition postulate states that if S is the interior of PQR, then the entire angle, the measure of this angle, is equal to this angle, PQS, plus the measure of SQR. So they can be different measures. They don't have to be equal. All it's saying is that the entire angle is equal to this plus this. So if I said that this is 30 degrees and that this is 20 degrees, for example, the measure of the whole angle would be 30 plus 20. So that would mean that it would be 50 degrees. So angle addition is you can take different parts and add them together to make up the whole larger angle. Alright, so using those two different ideas, we're going to go through and answer our next two examples. So example 3, we have a couple different angles drawn for us. And example 3 asks us to draw an angle bisector for each angle. Now, you could go through and find the technical middle point. And you can do that using a compass and a straight edge and doing a construction. We're not going to worry about the technical exact spot. We just want to make sure that you know what an angle bisector looks like and what it does. So again, an angle bisector cuts the angle in half. So kind of figure out about where your middle point would be. Doesn't have to be super precise, but let's say that my angle bisector is about there. So that's my drawing for my angle bisector for this one. And remember that an angle bisector means that this part is equal to this part. So by putting these in the corner, this represents that this angle is equal to that one. All right, I'll do one more. So if we look at our second one, okay, just kind of figure about where your middle point will be. And you're going to go through and draw one. So that looks pretty close to about what would bisector cut my angle in half. And then remember that an angle bisector cuts it into two equal parts. So this part is going to be equal to this part. So they have the same measure. So angle bisector cuts the angle in half and divides it into two smaller angles that have the same measure. So that is how we're going to deal with drawing an angle bisector. When you get to the homework, just locate the one that looks like it's cut it in half. And that's all we're going to be really worried about for angle bisectors. All right, last example. So example 4 here is going to ask us to use the angle addition postulate to find the measure of each angle. So if we look at example 4a, so it wants us to find the measure of angle CXE. So CXE is going to include these points. So if I refer to my angle here, okay, my angle is going to be that right there. Now, there are a couple ways that we can go through and do this. What I'm going to do right now is going to help you set up for your homework, but we're going to go through and find the measure of each of these parts, so that way we can go through and find this a little bit easier. So if we look at angle AXB, so this part right here, okay, we have to go through and figure out the measure. So if we start at 0, and it goes from 0 to 40, okay, the measure of this angle right here is 40 degrees. If I continue on to the next one for BXC, so it goes from 40 to 70. Well, the amount we've increased to get from 40 to 70 is going to be 30. Now, you would apply that idea as we move around, how much we go from 70 to 110, and then, not 110, 115, and then 115 to 150, and then 150 to 180. To kind of expedite this process, the measure of these angles is 45, 35, and then 30. You might reference this diagram either in the video or on my completed notes, because the homework kind of flashes back to a diagram similar to this, so use this as a guide. Now, if we're talking about CXE, CXE is made up of CXD and DXE. So it's these two parts, and I know the measure of this part is 45 degrees, and the measure of this part is 35. So the whole thing is going to be 45 plus 35, which means, if I go through and add them, the measure of angle CXE equals 80 degrees. Be sure to put the degree symbol on it. If you do not attach the degree symbol, you're just saying 80, and we don't know what 80 you're talking about. You're talking about inches, feet, centimeter. Okay, yes, I realize that we're talking about angles and it's degrees, but the site is going to want you to be particular, so be sure to enter degrees when you type in the measure of your angles. All right, so our last one here for example 4b. So it wants us to figure out the measure of angle KLM. So we need to figure out the measure of this whole angle. Now, KLM is going to be this part plus this part is going to equal the whole thing. Now, they tell us the whole thing is 135 degrees. Okay? But what this question is wanting is for us to figure out what does y equal. Okay, so that is what we're going to go through and do. Now, remember, the whole larger angle of KLM, which is 135, is equal to this part plus this part. So it's going to be equal to 47 plus 16y. So the whole angle is 135. The two parts are 47 and 16y. So it's 135 equals 47 plus 16y. This is the essence of the angle addition postulate, where the two smaller parts add up to be the whole larger thing. Now, this problem wants us to go through and figure out what y equals. So you're just going to use your basic algebra skills to go through and solve for y. So we want to get y alone. So our first step is to subtract 47 to both sides. So when I subtract 47 to both sides, 135 minus 47 is going to be 88. So I end up with 88 equals 16y. And then that 16y, if you recall, implies multiplication. So 16 times y. So the opposite of multiplying is dividing. So I go through and divide by 16. Cancels out on the right. And 88 divided by 16 is going to be 5.5. So y equals 5.5. So there's a couple ways to use the segment addition postulate. The first way is taking different angle measures and adding them together to find your result. The other way is using it to set up a problem that you need to go through and find the value of x or y or whatever it is. Okay, just remember, angle addition postulate, the two smaller angles add up to be the whole larger. All right, so that is our lesson for section 1.2 dealing with angles and their bisectors. Hopefully you have walked away with something useful and you feel comfortable about our two learning goals. That is it for today, and that is it for your video. If you have any questions later, just let me know and I'll be more than happy to answer whatever questions you have. So that is it for this video and this lesson. I hope you have a great day and talk to you later.